let's look at some examples. So we want to, on this first one here, we want to choose the graph of this function. But let's just break this into pieces, right? So what we want to always do is, what form is this in? What do we call that?
No,
It's a quadratic function, but it's written in a specific form. This is our graphing friendly form, right? What do we call that? Not general. Standard is the one where it's ax squared plus bx plus c, right? Which we use a lot, but that's not very convenient for graphing, right? So let's get our phones away, please. So what about what's this one? It's the one where we can see the dilation factor and the vertex, right? We can see the vertex.
Vertex form.
Vertex form. There you go. Okay, so vertex form of a quadratic function is just the one where the parameters a, h, and k show up, right? H and k are the coordinates of the vertex, right? So just a times the quantity, what?
I know. X minus. I don't remember that one.
H.
Oh,
right.
Plus K.
Squared plus k. There you go. Good. And so what are the values of our parameters here? What's a equal to?
Negative 1/2.
Negative 1/2. Good. What's h equal to?
Plus 5.
No. H is what's being subtracted from x, right? So it's negative 5. Remember, that's the one that's always going to be the opposite of that operation. It's being subtracted. So h is negative 5, and k is the easy one. That is negative 3. Good. Okay, so let's just go through this step by step. Well, I'm gonna change this around a little bit compared to what we did in the past. As I was writing these solutions, I just thought this is the way I'm gonna do it from now on. We're gonna do it in this order. We're gonna go ahead and just dilate the parent graph first, then we'll translate. I think the dilation is easier to do if it's starting off in a convenient place. If it's starting off with the vertex at the origin, right? So step 1 is going to be this. Step 1 is going to be, we're going to take our parent graph. And what is the parent graph? What's the graph that we're starting with to transform it into this one? So we'll call it P of x.
It's that.
Well, no. What kind of function is this? We've done all kinds of crazy stuff to it. It's a parabola. What's the most basic equation of a parabola? Y equals x squared. So our parent graph is just P of x equals x squared, right? So step 1 is just going to be, we're going to take our parent graph and we're going to dilate it, right? We're going to multiply the function by negative 1/2. So let's look at that and see what that does. Okay.
Flips it over and divides it.
So there's our parent graph, right? Everybody agree? That's our y equals x squared.
Yep.
Okay. So if I multiply that by negative 1/2, look at those points. These are just the regular points on our parent graph. We know we go over 1 and up 1, right? This is the graph of y equals x squared. Over 1, up 1. Over 2, up 2 squared. Over 3, up 3 squared, right? Which one of those y values would be, and let me go ahead and do, darn it, what was that thing? Let me do this. Which one of those y values is going to be convenient to multiply by negative 1/2? Because that's what we're trying to do, right? 2, 4 is, yeah, good, right? 2, 4 is. Okay, so then, so we'll do this. We'll only keep that point. Right, so we'll only keep that point. I know you can't, oh darn it, I know you can't see this, but you will in a sec. Okay, so we'll just keep that 1 point, right? Now the next step is to multiply that by negative 1/2. So if that's 2, 4, 4 times negative 1/2 is what? What's 4 times 1/2? 2, right? And then negative 1/2 makes it negative 2. So that point right there is going to get dilated down to right there, isn't it? Okay?
It's gonna flip over and be half as much.
Yeah. Oh. Okay. There it is, right? So there's step 1. We dilated the function, right? Okay, so what's step 2 going to be? We got it dilated. Let's keep track of these. So step 1 was we'll call it Q of x. We made one tweak. Okay, now what?
You go.
What's this telling us?
Right 5.
Okay, that's telling us to go
Left 5.
left 5, because h is negative, right? So this is saying we're going to go left 5, and what's that saying?
Down 3.
Right? That's it. Then we're done, right? So now we'll go, we're going to go from there. We're just going to translate it down. And we'll pick the convenient point, right? We'll pick the point that's at the origin. And what did we say? We're going to go left 5 and down 3. And so it just ends up right there. And we're done. Right? No big deal. Okay. That make sense?
Mm-hmm.
Okay. All right. Let's do next one. Okay, how about this guy? We're going to go backwards. So this time we're starting with the function, the graph of the function, and we want to write the function that corresponds to that. Right? Okay, so let's start with, just like before, let's start with our parent graph. Okay?
Oh, I remember how to do this.
What's that?
I remember how to do this.
Remember this stuff? Okay, so if we start with our parent graph, now think about our transformed graph. It gives us a convenient point that's over 2 to the right and up 3. So we're going to pick the point on our parent graph that's over 2, right? Because they have to have the same, they have to have the same x values, right? So if we go over 2, 2 squared is 4. So we're starting with the undilated point. The one that we're starting with is over 2 and up 4, right? So there's step 1. Okay? So there's our undilated point. Now what do we have to do though? We have to get it to go from, oh, you can't see that. Whoops. We have to get it to go from there down to there, don't we? Because this point is over 2 and up 3. So what do I have to multiply a y value of 4 by to get 3? 4 times what equals 3? Well, we could find out, right? We could easily find out. We could just
Find something.
solve for a, right? Because that's what it needs to do.
0.75.
0.75, yeah. Right, so step 1, this time, is we know that 4 times a has to equal positive 3, because that's what we ended up with, right? So we dilated it to get that graph. So a, if I divide both sides by 4, equals 3/4. Another way to think about it is final y value divided by starting y value, right? To get here, we're just starting with our original parent graph, and we're gonna try to figure out what were the things that we had to do to go from our parent graph to there. So first thing was we multiplied by 3/4, right? Okay, so let's go back and look at our graph then. So we're going to go ahead and multiply by 3/4. We're going to call this d of x for dilated, right? And that's what we ended up with. Okay, there's our dilated graph. Didn't do very much. All it did was pushed our parent graph and squeezed it down, so that point that used to be up 4 is now up 3, right? What's next? We got to turn the green graph.
So you
into
gotta
the blue
go,
graph.
your H and K. have got
Okay,
to
so
be-
what are the values of H and K? It looks like they're,
Negative
we're going to go,
4,
H is -4, we're going to go left 4, and what's K?
6.
Positive 6, right? So we need to take the green graph and do that. So step 2 is going to be, so what do we end up with for step 1, I guess? Guess we better finish that part. So step 1, at the end of step 1, we got d of x equals 3/4 times our parent graph, x squared, right? But now we need this thing for step 2. We need it to go left by 4 and up by 6. So left by 4 means what? H is, well, -4, but we're going to subtract it, right? So H is -4, up by 6 means K is 6, right? Positive 6. And so then we got to put this thing into vertex form, right? So we're going to say now our next step, which will be, we'll call it f of x, I guess that's our final answer, is going to be 3/4 times x minus h plus k. And we're just going to sub those values in, aren't we? Right, because we know we want to go left by 4 and up by 6. So what's our final answer look like then? F of x equals 3/4 was our dilation factor. It's supposed to be squared, isn't it? Times x minus -4 is x plus 4, and that's squared, plus k, which is 6. Right? No big deal. Okay. So let's look at that. So there's what we said, right? 3/4 times x plus 4 squared plus 6. And it did what it was supposed to do. Right? Look, the blue graph is the same as the blue graph, isn't it? Right? And that's how we got it. Okay. We figured out how we had to dilate it first and then where we had to translate it. Okay? How about, let's do next one. Okay, what about something like that? Let's figure out what the parameters are. We're trying to graph this thing, right? So it's in vertex form, isn't it?
It looks like this.
And it's going to do, we have this additional thing going on out there. So we've got this, we're multiplying the whole thing by -1 at the end, right? So what is, though, inside the parentheses, because here's our function before we reflect it, what's the value of a?
1/4.
Yeah, so we know a is 1/4. What's h?
6, -6.
Okay, good. So hk equals -6, +1. And then at the end, we've got to remember, what do we do if we multiply the whole thing? We multiply y, which is the whole function, by -1. What does that do?
Flips it.
Flips it over what?
The y-axis?
No,
X?
the x-axis, right? So we got those, we got some stuff to do. So the first step is gonna be, just like before, we're gonna dilate it, right? So if we take our basic parent graph and we multiply by 1/4, what's that gonna look like, right? So step one, we'll call it d of x, is just gonna be 1/4 times our parent graph, right? Okay, so what's that going to do? There's our parent graph, right? So which is the convenient point? If we're going to multiply by 1/4, we're going to multiply the y values by 1/4.
2/4.
2/4 would be the good one, wouldn't it? Right? That's the one we want to multiply by. Over 2 and up 4, right? Not 2/4, but over 2 and up 4. So if I multiply that y value, what's 4 times 1/4? Good, 1. So when we dilate this, we're only going to use the point that's over 2 and up 4, and we end up with that. Everybody agree? Multiplying by 1/4, just squeeze that point down to there. Okay, so there's step one. Good. Okay. What's step two going to be?
Left 6.
Left 6,
Up 1.
up 1, right? So step two is we're going to translate. So then we'll call, how about if we just, for now, we'll call it t of x, because it's the translated one, right? So t of x is going to equal 1/4 times what? How do I go left by 6? Ken, what do I have to do to make this thing go left by 6? Right, so this is telling me that h is -6 and k is 1. So if I want to add that information into vertex form, what's that going to look like? X minus -6, right? So plus 6 squared plus 1, and there it is right there, isn't it? Right?
Yep.
So that translates it. So let's do that part.
Wait, did it make it a -1?
No, no, because remember, k is just out there. K is the easy one.
Oh,
H
yeah.
is the one that's
Yeah,
backwards,
exactly.
that's being subtracted. You don't have to worry about that with k. Okay, so here's the next step. Right? Everybody agree? We from the dilated green function now, that was step one. We went left 6 and up 1 to get the purple, right? So there's the end of step 2. But then there's one more step. What do we have to do now?
Multiply everything by -1.
Okay, we got to reflect it, right? So if we multiply the entire thing by -1, that means we're going to take that purple function and we're going to reflect it over the line y equals 0. So there's the orange line, right, that we're going to reflect it over, the x-axis. And then don't we just end up with something like that when we're done? So that's our function, isn't it? Right? The blue function is what we end up with. We went through some steps. We dilate, we translate, and then we reflect. Okay? Make sense? All right, so let's look at one more. How about something like this? We're going to choose the graph of this function, right? So this really doesn't change things very much. The only inconvenient thing here is that we're starting off in standard form, right? But what do we do if we start off in standard form? We just need to put it into vertex form, and then we're set, right? And we don't even really have to write it in vertex form. When we did these other problems, like we started off with one right there that was in vertex form, right? Did we really need it to be in vertex form? Not really. All we needed to know was what were the values of A and H and K, right? We took those from vertex form. Once we knew what those were, we could go find the graph, right? Okay, so we don't even really have to write the function out in vertex form. We just need to know what A and H and K are. Right, so what was our trick? Well, what's A? That one's obvious.
3.
A is
Negative.
-3. Good. But we need H and K. Now, to get H, we had to remember our little formula. What are the values of A, B, and C up here? You already told me A is -3. What's B? Because this is in standard form, right? A quadratic function in standard form just looks like ax squared plus bx plus c. And that'll look pretty familiar because when we've been doing our factoring, we've been starting in that form, right? So what's b?
6.
Good. What's c?
-6.
-6. Okay, what was our formula for finding the value of h if we know a, b, and c?
Plug it back in.
Wow.
Wait, no. It's that one that has division in it,
Yeah,
the line. Ax over -b
it's negative b
Oh, shoot.
over,
ac.
no, I think I heard
A.
it. 2a, there you go. So we can plug stuff in there. So negative b is just -6, right? If b is 6, then negative b is -6 divided by 2 times a. Well, that's just -6 over -6. So what's h?
-1 or 1.
1. Good. H is 1. Now, how do we find k? That's what you're going to tell me. How do we find k? That's a y value.
Plug it in.
Plug it in. Right, to find a y value, you just plug the x value into the function every time, right? So k is just going to be f of h. So that's just f of 1. Well, if I plug 1 in, that's easy. What do I get? -3 times 1 squared is just -3, right? Plus 6 times 1 is 6, minus 6. Well, -3 plus 6 minus 6 is just -3, right? The 6 is canceled. So that tells us that the vertex has to get translated to the point 1, -3, right? So now we know A and H and K. This is just a 2-step problem. No big deal. All we got to do is dilate it and then translate it, right? We start with our parent graph. So here's our parent graph, right? I guess I'll go on this side so we can see A and H and K. You still can't see it great, but you get the idea. A is -3. Here, let me do this. Let me write it over here so we can see it. Guys. There we go. Okay? So then, what's a convenient point? If we're just going to be multiplying by -3, what's a convenient point to use? We don't need to use anything fancy. We'll just go over 1 and up 1, right? Because if I'm multiplying the y value by -3, let's just multiply the easiest y value, which is just 1. Right? So we can just do that. There's our parent graph. So we're going to multiply the y value by -3. Well, what's our current y value is 1. What's 1 times -3? -3. Right? So we end up with, after we do our dilation, we just get that. Right? The dilated point, instead of going up 1, now it's going to go up by -3, which is just down 3. So there's our dilation. We stretched it and we reflected it because it's negative, right? Now we're just going to translate it. So we're going to take our green dilated graph and we're going to go where?
Over 1, right 1, down 3.
Down 3, and we're done. That's it, right? Okay, so there it is. That's our answer, right? The blue one's our answer. Okay, that makes sense? Okay. Why don't you guys just work on this stuff a little bit? How about it? Okay. I don't have this review up yet. I really wish I did, but it'll be up. I've got this done. I'll put this recording up. I'll put the notes up so you can look at them. Okay. And it'll be up probably by tonight, I think. Okay. So you guys can just work on stuff for the rest of the period. I had one more example, but I think that's good enough. I think you get the idea. Is that ringing a bell? Remember how to do this stuff?
Yep.
Okay.
Will they have it in words, like, on how to set it up, like